tape loop of the sun itself with satellites traveling around it that are sponsored by both NOAA and NASA. And it's really a huge nuclear furnace, fusion going on, an unbelievable amount of power. And of course, at 93 million miles away, it feels very nice in your cheek on a very cold day out there. Now, these yellow areas, you'll see them flare out every so often, are called flares. The hot gas and material flare out with almost a huge explosion. Usually the magnetic lines, the great gravity of the sun pull it back in. But that's really why our satellites are out there. Sometimes they're so energetic they break free of the surface of the sun and head outward. And if they're heading to Earth, it can be a little bit of a problem. Now, we can radio back from those satellites to Earth saying, look out, a flare is heading towards us. And that takes about 8 minutes at light speed. Luckily, the material from the flares take 3 or 4 days. So the folks on the International Space Station get into the more shielded areas. Here on the ground, we can double check and make sure our electrical grids are safe, because we can cause blackouts with those. Satellites traveling around the Earth, they're delicate that can be turned off until it is safer. So even though the sun can cause problems, it's also our life giver. Now the planet that's closest to our sun is Mercury. Almost looks like a more blasted image of our moon. And it's really too close for those things we think that need life. Water, liquid water, an even temperature. You can melt lead on the surface of Mercury. So if you're going to look for life or someplace you'd like to stay for any amount of time, Mercury isn't it. For many, many years, actually, the next planet out, Venus, was thought to be a lot more hospitable than it is. It was even called the twin of Earth, almost the same size, a little bit closer to the sun. But Venus was always enshrouded with thick clouds swirling. We couldn't look through with our telescopes. So, of course, they thought liquid water, clouds, possibly, about the same size of Earth. Maybe there are jungles down there. Science fiction authors writing about dinosaurs in the jungles. Well, the reality not quite so nice, I'm afraid. When we got into orbit with the spacecraft, the Mercury Messenger, a Venus Messenger, we could peer through the clouds with radar, X-ray, and we found a very hot, blasted surface, about 800 degrees Fahrenheit. And the reason is the clouds. They act like a huge greenhouse, trapping the sunlight, bouncing it back and forth, and the temperature just runs away. Also, those clouds are not water vapor, but concentrated sulfuric acid, so insult and injury. Again, a search for life, this isn't the place to look. How about the third planet out? Planet Earth. Ooh, I can see my house from up here. No, I can't. Well, we're pretty sure life exists here, we exist. And part of the reason is that huge blue area, more than 3/4 of the surface, liquid, warm, salty water, our oceans. We think, as people here on Earth, that you need to have warm, liquid water to support life and an energy source like the sun. But the sun may not be the only energy source, as we'll see in just a little bit. Now the continents, the green areas are greenery, some jungles, other areas. There's some deserts scattered around. If you were an alien coming in from another star system, this looks inviting to you. Do you think there's life there? Well, to look for life, perhaps, the best way to do that is to look at nighttime. Well, coming in at night, you see electric light shining. And you'll notice a lot of the shorelines have that. A lot of the early civilizations began on the shore with the trade routes. They built up and, of course, became electrified. But you'll also notice in the North American continent and Europe, squiggly, very bright lines. These are actually the highway systems from the 20th century. And again, civilizations and towns and cities springing up along those lines of commerce. As a matter of fact, some of the telescopes on Mauna Kea in Hawaii, some in Chile now, they are very high up so you can see through the atmosphere pretty easily. And they are putting instruments on to look towards planets around other stars, looking for electric light. Probably somebody there lighting lights at night too that might be out there to get in contact with. Now, we've had a light to look at during our history, not that far away, 240,000 miles overhead, our moon. I think the most interesting thing about the moon is, though, only one face of it faces Earth. And I'll turn it so the people on my left can get a pretty familiar looking view. Bring it around to the right for a familiar view too. That dark area above, Tycho crater below. Now the reason we only have one face facing Earth at a time is that dark area. Nowadays the moon is volcanically dead. It's a solid object, we believe. But millions of years ago, there was volcanism there, a liquid core. And that dark area was where the volcano spewed out the lava where it hardened. And that material was more dense than most of the surface of the moon. It's heavier, if you will. And the gravitational attraction between Earth and the moon pulled on that more, slowed it down until only that one face is facing us. But the opposite side, if you look at a map of the far side of the moon, most of the features of the rills and the craters and the mountains have Russian names. Because it was only in the 1960s that the Soviet Union first sent a probe around the moon, taking pictures, transmitting them back to Earth. And since they discovered the features, they got to name them. The next planet out from us is the red planet Mars. And yes, it really does have this color. You can see it even with your naked eye. Small disk in the sky. And the scientists, as well as science fiction authors, thought there might be a chance for life here too, because with our earlier telescopes, even in the 1800s, looking through the atmosphere, we saw at the poles that there were ice caps. Now, in the summertime, they would shrink. Those darker areas around the equator would get even darker. We couldn't see them that clearly, but perhaps it might be vegetation down there. When we sent a probe whizzing by Mars, taking a few snapshots, we saw all these craters. We thought, oh no, cool again, another dead world. Well, not so fast. When we had a later spacecraft get into orbit, we're regionally taking photos that are high-quality pictures. We saw there were dry lake beds, riverways, deltas. There once was a lot of water on Mars a long time ago. What happened to it? Did it all go through its atmosphere into space? Is it underground? Well, actually, just a couple months ago, with some of the high-definition orbiting cameras and instruments on board Mars orbiters, we've seen that there are areas that have subsurface frozen water. So a lot of the water is still on Mars, but not accessible to the surface right now. So the jury is still out on whether there was or is life on the red planet. When we leave Mars, we'll be heading towards our first gas giant, and that's Jupiter. Now remember, we're projecting all these planets and moons on one side sphere, but Jupiter is the largest planet in our solar system. You could put over 1,000 Earths in there. Great red spot coming around in the southern hemisphere, that huge hurricane that's been blowing for about 400 years at least. You could fit about 4 Earths side to side. Now, again, a gas giant, mostly helium, hydrogen, some methane, other trace materials. Just a couple months ago, we put the Juno spacecraft into orbit around Jupiter, around the poles, and it dips down to less than 1,000 miles above, getting closer and closer. We're going to be tasting some of that to see what the constituents are, as well as looking to see if there's a rocky core down there. All the millions and billions of years Jupiter's been there, it's with its gravity and then tracking things into it, saving the Earth from a lot of asteroid strikes also. So we're not quite sure what's down there. We're going to take a look. Jupiter, though, has a very interesting set of moons. And I think if you're looking for life, Europa is the place to look. And NASA does think so also. We first took a few quick pictures when the Voyager probes went sailing by. With our first probes around Jupiter, we took more leisurely pictures. The surface of Europa is frozen water ice, a lot of it. It's about 20 kilometers thick. These cracks and creases on the surface, though, let liquid water rise through and refreeze. And because of the color, we think there's there is a huge saltwater ocean under Europa. So this might be a place to look for life. Here on Earth, in the very deep oceans where sunlight doesn't penetrate at all, where there's small smoky volcanoes spewing out material from inside the Earth that actually feeds animal and plant populations down there. So a whole different ecosystem. And if there's a rocky volcanic core on Europa,